So for the first two are about graphing. For number 1, do we have growth or decay? Grant. Decay. Okay, we have decay because our B value is 1/3. Okay, what is our domain, Tommy? Good. What would be our range, Catherine? It's Caitlin. Okay. Yeah, Caitlin. Why? We have a reflection, okay, which flips it over the x-axis, okay? So what is our horizontal asymptote? Jax. Y equals 0, okay? What is our y-intercept? Kip. 0, -6, okay? So if you started, and some of these points are going to be off the graph. So if you started with our table of values, okay, just with our parent function, which is 1/3 to the x, you have 9, 3, 1, 1/3, and 1/9. Then if you were to multiply them by -6, that takes care of the reflection and what else? What else is happening? Vertical stretch. Good. So clearly we're going to have what for a new y value here? 9 times -6. Okay. 3 times -6. 18. -6. -2. -6/9, which you could reduce. But we know, we know our horizontal asymptote is y equals 0. Okay. If this is a decay function, which it is, it would be going in this direction. But since it's reflected, it's going to be going like this. Okay. So when we plot these points, okay, we have 0, -6, 1, -2, okay, 2 and 2/3 will look like this. Okay. The reflection and the stretch both occur. Do I expect you to graph -54 and -18? Absolutely not. Okay. But so you know the direction of the graph, the table helps you see that. Okay. Now number 2, Campbell, growth or decay? Growth. Good. Zoe, what's our domain? Good. Kate M, what's our range? Good. What's our horizontal asymptote? Equals 2. Excellent. And our y-intercept, Caden? 0, 3. Okay. So again, if you chose to use the table of values, over 16, okay, but we know everything is moving up to, so we have our horizontal asymptote denoted by a dashed line. So this is 0, 3, 1, 6, 2, 16. Okay, and you will have this graph. Okay. Any questions on 1 and 2? Now we have our word problems. Okay. The equation represents the value of a car over time. Okay, 5,000 times 0.624 to the t, where t is the number of years since the car was purchased. What is the original amount of the car, Pearson? 5,000. Good. Anytime, it would always be this value, or if you needed to do t equals 0. Okay. Does this equation represent exponential growth or decay? Christian. What is it? Decay. Good. Because 0.624 is less than 1. Okay. Now state the growth and decay factor. That's what's in the parentheses, okay? So the decay factor is 0.624. Well, what's the percent of increase decrease? How do we find it? Yep. Careful. 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 It's okay. Kip. 1 minus r because it's decreasing, okay? And this is our decay factor. Well, the formula for decay factor is 1 minus r. So what does r equal as a decimal? Kaden? 0.376. Now, what would that be as a percent? Yeah, go ahead. 37.6%. That would be your percent decrease. Okay. Number 4, the equation represents the amount of bacteria over time. State the original amount, KR. Good. Okay. Does this equation represent growth or decay? Eliza. Growth, good. It's 1.257 is greater than 1. Good. State the growth or decay factor. Noella. Okay. All right. Eleanor. The growth or decay factor. So, now, did you just say 0.257 or 1 point? Okay. There you go. Sorry, didn't hear that first part. Okay. Then, since we have growth, okay, 1 plus r equals, what is our rate as a decimal? Jax? Our rate is 0.257, so we multiply that by 100, and 25.7%. Yes. Because the decay factor is less than 1. This value is less than 1, so it's a decay factor. So this comes from what they already did was take 1 minus 0.376. They already did that to get 0.624. This is greater than 1. So that's our b value if you look at it in exponential. A times b to the x. They already took care of this part for you. It's already done. It's already done. Yep. Great question. Okay. Now, number 5, you had to classify if it is growth or decay and determine the domain and range. All right. So number 5. David, growth or decay? Decay. Good. Okay. Domain and range. James. Okay, and what's our range? 4 to infinity. Okay. The reason it's 4 to infinity, there's no reflection here. Okay. For B, Gating, growth or decay? Growth. Good. So we have 5/4, which is greater than 1. What is our domain and range, Charlie? Good. Excellent. Okay. And how we know the range? It's based off of our horizontal asymptote. It would change either or depending if there's a reflection. But it's always our horizontal asymptote. Yep. For B, yeah, that's why it's negative infinity and negative 1. Negative 1 to infinity. Okay? All right. And then number 6. Similar idea as what we just did. However, now we're doing some calculator work. Okay? So what is the original price of the car, Victoria? 24,000. Good. Okay. What is the decay factor? Grant. Good. Okay. Now, since that's the decay factor, R is already done. So it's 1 minus R equals 0.745. So what is our percent decrease? Tell me. Careful. Careful. Yep. 25.5%. Okay. How we get this? Again, in the parentheses, this formula is already done. Okay. So since it's less than 1, our decay factor is 0.745. In order to find the rate, we have to work backwards. Okay. So 1 minus R equals 0.745. We subtract the 1, divide by negative 1, and we get 0.255, which is 25.5%. So for D, after how many years will the car be worth 15,000? Okay, and I know you get a decimal, so the nearest year, I guess. How do we set this up? Yep. Yep. Okay. Yep. Okay. 1.5, 1.6 years if you said in between 1 and 2, or rounded to the nearest year, 2 years. I hate when it does that because it's in between, right? So 1.5 years would be fine for me, okay, if you were to put that, and put the actual decimal, right? Because how much would it be worth? You can't really say 1, you can't really say 2 because it's right in between, okay? So for that one, if you wrote 1.6, make yourself a note and say between 1 and 2 years, okay? Now, what is the value of the car after 20 years? Is this reasonable? Yep. It's not so reasonable. Good. So to get that, you plug in, set that equal, y equals, set t equal to 20, you get $66.58, which is not so reasonable for a car. Okay? So any questions, especially on D and E, setting the window, adjusting the window, knowing what to do in our calculators? Yep.
For the window, how do you know what to adjust it to?
Well, standard should be x min 0, x max 10 if you think it will fit. If not, you could always do just 50 blanket statement if you wanted to, because this represents your time. Okay. Now your y min and max depends on the problem. Okay. You could automatically, which I've done both, set your y minimum to 0. You could always set it at 0 and keep it that way. However, some of us like to see a better window like myself. So in this particular problem, I would set my minimum at, let's say, 10,000. Okay, because between 15,000 and 24,000, 15,000 is the lower one, but I want to actually see the line crossing, so 10,000. Your Y max can be your highest value, which was 24,000. Since it's is decreasing, we really don't need to see the top, the 24,000. If it was an increase problem, and this was my highest number given, I would do 0 to like 30,000. Okay, I look at the two numbers given, your A, which is this value, and your P. I look at those two to determine my Y value window. Okay, and again, it takes some getting used to just to adjust the window. When you hit zoom in and out, doesn't always work. Okay, doesn't get close enough. You don't see both lines. If you were to, in one of the examples that we will see, again, if you do see both lines within your window, but they're not intersecting, your intersect tool will not work. It will give you an error message that says no sign change because it doesn't see it. So if you saw something like this, what would you have to adjust? Yep, you would have to increase, excellent, your X max, okay, to see it. Your Y min and max are fine. You would have to increase your X max, okay? So when you do these word problems, you want to be exact, okay? That's why the calculator and using the calculator is imperative, okay? Yep. Yep. Not all the time. If there's a reflection and a move up, then it will be above the x-axis. Okay? All right, but your range will always be negative infinity to whatever. Okay? One thing on the homework, you guys only had 4 problems to do. Number 7, I ended up adjusting when you guys left here. Okay? It originally said 2023 for number 7. 2023, so your T value would have been 1, okay, from current. I ended up adjusting the T value to 2026, which would have been 4 years. So if you had this set up for number 7, to the first and then solved, you would have been correct. If you did to the 2, like it said on the key, that was fine. But from 2022 to 2023 is only 1 year. Okay. I ended up, that's why in purple, if you saw on the key, it was adjusted to 4 years. Because after you guys left, that's what I changed to. For number 6, you had to solve for the rate, okay, which we haven't seen one of those problems on the practice. So how did this go? Do we have any issues? Good? Okay. All right. So if you look at your notes in the packet that you currently have open from the homework, turn to 5.7, which is the last lesson in this unit, page 9, okay? And keep in mind there will be a test when we get back on Wednesday on exponentials, okay? You will get the review. There will be absolutely no homework over break. None, okay? We will finish as much as we can between today and Wednesday. Again, no homework over break. Okay, yep.
What's the final day of break? Is it like
The 22nd, that Friday. So we get back the 25th. Okay? And there's no school Friday as well. So, all right. This last lesson is about compound interest, okay, with the interest word problems. You're looking for, again, we have 2 additional formulas, okay? One is compound interest over a specific period of time, and then you have compound continuous, which is at a continuous rate in a different formula. So, compound interest, here is the formula. The only thing that is different is the n, okay? The n is number times compounded per year. So examples of that would be semi-annually, quarterly, monthly, weekly, daily, okay? If it's compounded a certain number of times per year, that n value would change. But if you notice, it's r over n, and then it's raised to the nt, okay? Compound interest is a growth model, so that's why we have 1 plus r over n. Your rate is still written as a decimal, okay, no matter what. But n is in 2 places, okay? Then if you have compounded continuously model, you're constantly earning interest, and the interest keeps earning on interest, and blah, 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 keeps happening, okay? Keyword here, to know the difference between these two formulas, it must say continuous, okay? If it says compounded continuously, you are using the PERT formula, okay? Which you guys actually saw this determining if it was growth and decay on the 5.5 practice. Okay, so A, P, R, and T are the same. E is actually in your calculator. Okay, it's a button in your calculator. And if you look at your calculator right now, it's second ln. ln is below the log key. Okay, second ln is E, like this E value. Okay, it's an irrational number, yes. That's a lowercase e. Okay, could be. I don't know. I always use the one e to the x. All right. So, compounded continuously is the PERT formula. Compounded number of times per year is compound interest. All right. So, let's try a few to see how it changes. You deposit $4,000 in an account that pays 2.92% interest. Find the balance after 3 years if the interest is compounded with the given frequency. Okay? We're going to round to the nearest hundreds because we're talking about money. All right? So quarterly, that's our n value. How many times per year is quarterly? 4. Okay? So, A equals P is my initial amount, which is how much? 4,000 is what we deposit. Now it's 1 plus. You must remember the 1 plus. It's never a minus because it's interest. It's growing. Okay? 2.92. How would I write that as a decimal? Thank you. Okay, 0.0292 over 4. And 4 times how many years? 3. Okay. This is what it looks like. Yep.
Does it reach why n equals 4 because of 4 now?
Nope, n equals 4 because of quarterly. Okay? All right, so in your calculators. Okay. Bunch of you would be, just be careful how you enter. What I typically do, 0.0292, divide by 4, because it's quarterly, then plus 1. I do everything in my calculator. Then I take this number and raise it to the 12th, because 4 times 3. And I multiply by 4,000. This is one way, okay? So you don't... This is one way by splitting it up. The other way I'm going to show you, you have to have parentheses in specific places, or else you'll get a totally different answer, okay? So after 3 years for quarterly, amount would be $4,364.82. if you were to enter all together 4,000 parentheses 1 plus, you need parentheses around that fraction, 0.0292, divide by 4, close parentheses for this fraction, then close it again for the 1 plus, and raise it to the 12th. Or you get the same answer, okay? If you do not have parentheses around this here, what it would do is take 1 plus 0.0292 and divide that by 4, which is incorrect, okay? So either way is fine as long as you get the correct answer, okay? So what is going to change about this equation if we went to weekly? Grant? Good. Okay. Instead of n equals 4, it'll be n equals 52. Everything else is the same besides where n is. Back to the calculator. Okay. How many of you did get this amount? Let's see, not a lot of hands. All comes down how you enter it. Yep. 0.10. Okay. And the last one is compounded continuously. Are we using the same formula as A and B? No. We will be using the PERT formula, which is A equals PERT. Our initial amount is 4,000. E is what we find in the calculator. It's an irrational number. Times our rate, which is 0.0292, times 3. Okay? Excuse me. So we have 4,000. Second ln. E21. And then let me try the David way. But then you have to do that. Okay. You have another E here as well, but you have to put the caret. That's why I like this one, e to the x, because it does it for you. Puts it in the exponent already. Okay? So, if you have compounded quarterly, weekly, daily, even annually or yearly, the n value is going to equal 1. Okay? Semi-annually is 2, quarterly is 4, monthly is 12, weekly is 52, daily is 365. Okay? So, when you see compounded specific number of times per year, it will be your n. Keyword continuously will be the PERT formula. All right? Any questions? Oops. Okay. So for number 2, how long will it take to double your money if you invest it at a rate of 6% compounded semi-annually? What if it is compounded daily? It's not a leap year. So we have 2 questions going on here. Okay? So we want to double our money. Okay? What you want to start with is something very simple. Okay. I want to double my money. Easiest one to enter, say if my initial amount, I deposited $1. To double it, what would be my ending amount? 2, right? Very simple. Why make yourself crazy by putting in 100, doubling it for 200? You could, right? Keep it simple. So, our rate, 6% as a decimal would be what? 0.06. And our first one we're looking at, semi-annually. 2, good. We're finding what T is, right? So, we have 2 equals 1 plus 0.06 over 2 to the T. What do we have to do here? Huh? How? Doing what? What do you mean? Y1 and Y2. Okay? Y1, Y2. Okay? If we go to our calculator, go into Y equals, make sure you clear everything out. Anytime you want to get back to the main screen, negative 10 to 10, go to zoom 6. It brings you back to the normal screen. Okay? So Y equals 2. And we have that one. I'll just enter as is, but this one in front you really don't need. 1 plus 0.06 divided by 2 raised 2x. Okay, everyone okay? And you might want to jot down too how you put parentheses around it, okay, on your notes, so you have something to refer back to. Okay, yeah, right. Zoom 6. Zoom 6. It's the standard screen. Okay. You have to see the graphs first. Both graphs. So, if I hit graph, this is what I see. We're almost there, just not quite. What needs to be adjusted? Yeah. X max. So if I go to my window, I'll just do 0, 15. My Y minimum, I'll just do 0. And I'll leave the max as is. Okay, you must see the intersection, even though it looks like it is right there, it's not. Okay, here's where it would show the intersection. Second trace, number 5, enter 3 times, approximately 11.7 years to double your money. 11.7 years. Okay. So this would be okay. So now what would change about what I enter if it was compounded daily? Eliza. Good. Our n is 365. So we have 2 equals 1, and plus 6. Do you guys think it's going to take longer? Less time? Or the same amount of time? What do you think? Take a guess. Doesn't matter. Will it take longer to double your money, less to double your money, or the same amount of time? If it's compounded daily.
Daily rather than once.
Semi-annually. Okay. Like, we're cutting off a year, cutting off a month, multiple years. What's happening?
Is it doubling every day?
It is, how long will it take to double? So, at that interest rate, 365,
Do we know how
you're
much
getting,
time for the doubles?
no, you're looking to see how long it will take to double your money. It doesn't double every interest. Like this, we're trying to get to here, based off of that rate. We're seeing how long it will take to double. It doesn't mean that the, okay, all right, let's check. Y equals, let's see if I could. Looks kind of similar, huh? Slightly, very slightly. Interest is a funny thing. I just don't want to give you nothing, right? I don't want to give you anything. Yeah, Campbell. I just did, first it was on the standard one, right? So I couldn't see the intersection. So what I did is for my minimum, 0. My max, I just did 15, not knowing. My min, 0, and max is 10. You could even do your max is 5, because we're talking not a lot of money right now, okay? So you kind of look and play with the scale. You could have pretty much left it, your Y min as negative 10 to 10, and just adjusted your X max. Yep. Yep. Okay. So we're going to do some little more practice. But first, I'm going to look at number 4. Okay. This says, how much money would you need to deposit now if you wanted to have $40,000 in 10 years? If the bank offers 3.5% interest compounded continuously. So, first thing, what formula are we using? Compound interest or compound continuously? Continuously, good. Okay, so we are using the PERT formula. What do we need to find? What are we trying to find? Is the initial, which is what letter? P, good. So we know A is 40,000. P, we have no idea yet. The rate as a decimal, 3.5% would be what? 0.035, good. And our time is 10, good. All right, so we have 40,000 e to the 0.5 times 10. How do we solve for P? Just, what's your initial thought? What would we do here? How do we solve for P? Yeah. Careful, Jaden. Good. Okay, so all in all, you could do this all together. Okay, we are dividing by E5 times 10. Okay, so in our calculators, and you could do exactly what Jaden said. You could do that exponent first and then raise it to the E, or do that first. So let's see. I'm going to do second E this way, 0.035 times 10. Okay, then it was 40,000 divided by that answer. Enter. That's how much you would need to deposit if you want $40,000 in 10 years. Okay, you need to deposit $28,187.52. Okay, so you could have also done 40,000, and then I'll do parentheses. I never know with this thing. As well. Okay. Yep. If we plug it back in to see exactly what it would be. Okay, that's the only way to check. Okay, so we solve for P. Yeah, Jaden. Yeah, we solved for P. We found T in our calculator. Okay, what I want you guys to try is number 3 and number 5. Number 5 is comparing two banks at two different offers. Okay, so number 3 and number 5. All right, let's go through these two. Okay, for the third one, all right, you're trying to find T. Okay, looking at the calculator. All right, it will, and it says to exceed 2,500, say, over 17 years. You'll reach 2,500 at 17. Anything over 17, you will exceed $2,500. Okay, but this is where you would have to start Y1, Y2. Okay, how many of you did get that once you adjusted their window? Good. Okay, then you have Bank A, Bank B. Okay, Bank A is compounded quarterly, so our N is 4 at 4%. Okay, so you end up with this total for Bank A. The interest earned is this amount. We got that by taking our total minus our initial, right? Good. Okay. Bank B offers 4.15% compounded annually. Okay. So here we could really just have 1.0415 to the 10th. We don't have to include those ones. But you should have gotten this amount with this interest. Okay. Which one, very clear, would gain you more interest? Bank B, but how much more? Good, $128.69. Bank B would get you. Okay? Yeah. Number 3, 17 years. Okay? Pretty straightforward, right? It's just getting familiar with the formula. 2 different formulas. If you turn the last one for today before we get into practice, is finding the rate. Okay? We found P, we found A, we found T. Okay? The last one is P. You would not have to find N. Okay? You guys will not have to find N. It will be given to you. Okay? You deposit $2,670 into your savings account 3 years ago. You currently have $3,000 in your account. If the bank compounds their interest annually, what was their interest rate? Okay? So we're trying to find the rate. What is our ending amount? 3,000. What was our initial? Good. Now this is compounded annually. So you could do r over n equals 1. So it's just r. How many years? 3. 3 times 1 is 3. So from here, what do we do to find our rate? What do we do first? Okay. So once we divide, okay, 3,000, 2670, enter. Okay. So from here, to be exact, we could leave this as is, or we could round to, I think it says the hundredths place, your final percentage. So to be exact, you want the more decimal places you have, the better. But from here, okay, once we divide, what would be your next step? Take the cube root. So if I take this and raise it to what power then for the cube root? 1/3. It is. Enter. Then what would you have to do? You don't have to divide by -1 because it's always plus. If I multiply by 100, final percentage, round to hundredths place. Hundredths place, right? 3.96%. Okay. If you did, say from here, and rounded 1.124, okay, and then took the cube root, you would get close to 4%. Okay, either one. All right. Any questions, you guys? Yeah. Well, yeah. So we did a lot in terms of more formulas. However, we just finished exponentials. Okay, we just finished all of exponentials. Your homework will be in your blue packets. Okay, blue packet, pages 4 and 5, which is 5.6 practice. 135, pages 6 and 7, which is 5.7 practice. 2, 3, 6, and 7. Okay, just a few. It's all word problems. Okay. From our last lesson, exponential growth and decay, and then our interest problems. All right.